Guys, welcome to Algebra 2. This is Big Ideas Math, Chapter 6, Section 6, and we've been solving. And I'm actually going to fast forward this far, all the way to the more challenging problems, which are the ones we have left to do together. And then I will go back to the end after that. So remember yesterday, what we were talking about is that when you have one log on one side and not a log on the other side, all we have to do is rewrite it. Well, here's example 13. It's one of the last two we had to do. And you're like, whoa, oh no, there are two logs on this side. And there's a 2 on this side. There's a number. So I have not yet taught you how to do this. You cannot do something like this. You can do it when a log equals a log, or you can do it when a log equals a number. But this is a log plus a log equals a number. It's like, it's impossible. I can't do this. But don't worry, you can. We absolutely can. Because do you remember what it means when a log is adding with another log? Oh, right. Addition is really multiplication. And so to begin this problem, we have to recognize that this is the log of, notice there's an invisible base, so it's an invisible 10, and it's 5x times x minus 1. Whoa, what did she just do? Okay, remember our previous lesson on the product property of logarithms. What that says is if you have two logs and they have a plus sign between them, the of part multiplies. So the 5x and the x minus 1 are going to multiply. Now we're going to need to distribute that. So this is the log of 5x squared minus 5x, and it is equal to 2. Now, keep in mind that log is an invisible base 10. And so now we're at yesterday. Here we are, we've arrived. This is what all of our problems looked like the last lesson, or the first part of this lesson, and we know what we can do. We have one log equals a number, which means we're stuck. We're going to rewrite it. So this is really 10 to the power of 2 equals 5x squared minus 5x. Then we're thinking, all right, this is 100 because 10 squared is 100. And then now is when we really are like, oh no, because there's an x squared and an x, which means this is quadratic. And we are going to need to set it equal to 0. So here I go, subtracting my 100. And I get 0 equals 5x squared minus 5x minus 100. Now, go back to your brain. Somewhere in there, we learned how to solve these. Do you remember how? It's factoring. Yes, factoring is our friend. Factoring is fun. Factoring is my favorite. All right, so the first thing I do here is I factor out a 5. Now, pause me or something because you guys should be able to solve this from this point. You should have been able to solve it a long time ago. What do? You're thinking, what multiplies to make a negative 20 and adds to make a negative 1? Well, I can think of two numbers that make a 20 and a 1, and that's a 5 and a 4. I need to make a negative 1, though, which means the 5 has to be negative, the 4 has to be positive. All right, we factored it. Yay, good for us. Now we have to solve it. Okay, remember to solve it, you set everything equal to 0. So you have 0 equals 5, which, duh, it's false. You have 0 equals x minus 5, which is x equals positive 5. And you have 0 equals x plus 4, which is x equals negative 4. Okay, we have two answers. But before you circle them and you're like so happy to be done, guess what you must do? That's right. We need to check these answers. Because remember the log function, the parent function at least, has a domain where all of the numbers have to be greater than 0. So we're going to plug 5 in and see. So that's going to be a log of 5 times 5 is 25 plus the log of, I don't know what even is that. That's 5 minus 1 is 4. It's supposed to equal a 2. You can plug it straight in your calculator if you want, or you can go with the rule that you know you're allowed to multiply. So this is the log of 100 equals 2. So that's log of 10 squared equals 2. And the log invisible base 10 of 10 cancels, leaving 2 equals 2. Hey, guess what? 5 checked. Now let's try -4. If I plug a -4 in, I get the log of -20 plus the log of -5. Am I allowed to have the log of a negative? No, I'm not. -4 is extraneous. Extraneous means it's an extra answer that we got when we were working so hard. But oops, I'm sorry, it doesn't actually work in the original problem. All right, that was big. That took almost 6 minutes. Let's try the next one, the last one. Example 14, you read this. You've got a log base 2 of x plus a log base 2 of x minus 7. It equals 3. You're thinking to yourself, oh no, I don't know how to do this. There's 2 logs and it's equal to a number. Oh, but wait. We are allowed to multiply those of parts. So it's log base 2 of x times x minus 7. Got it. Equals 3. Now do the multiplication. So it's log base 2 of x squared minus 7x. Excuse me. It equals 3. Now we're where we were in the first part of this lesson, where we get to rewrite it because we have one log and then we have it equal to a number. So this is 2 cubed equals x squared minus 7x. 2 cubed is 8, so 8 equals x squared minus 7x. Now at this part, you should not need me. You should be able to finish this problem like a boss. So pause me and do it, guys. Do it. I'm going to set it equal to 0 by subtracting the 8 to the other side. I'm thinking about what multiplies to make an 8 and adds to make a -7. It's got to be an 8 and a 1. And in order to make a -7, it's got to be a -8 and a +1. I'm setting each of those equal to 0. I'm solving. I get x equals 8. I get x equals -1. Now I plug them in to check them. Log base 2 of 8 plus log base 2 of 1 equals 3. Well, this is like saying log base 2 of 2 cubed plus, now what is log base 2 of 1? Come on, remember your rules. Come on. What is it? What is it? What is it? It's 0. And then look at that. Log base 2 of 2 cancels, and sure enough, 3 equals 3, so 8 checks. Now plug in -1. You get log base 2 of -1. Oop, stop right there. -1 is extraneous. I didn't forget the E, but I can't get it to write. There we go. -1 is extraneous. How do I know -1 is extraneous? Because I'm not allowed to have the log of a negative number. Okay, those are your last 2 examples. I got them done in a little less than 10 minutes. I'm going to go back now and do the beginning of this file since I have time. But you guys could get working on your 6.6 worksheet in the packet. But for everybody else, let's come back here at 6.6 we're solving. There are 6 examples in your foldable. Okay, they're going to take up most of the pink space on the solve exponential functions. This is what we learned yesterday. This is what you want to write down. If b to the x equals b to the y, then x equals y. So like if 5 to the x equals 5 to the 7th, then it's pretty obvious x equals 7. But look at example 1. Example 1 says solve. It's 4 to the 3x equals 8 to the x plus 1. That's a 4 and an 8. It's not a b and a b, like how this was a 5 and a 5. See, the bases are the same. So what we do is we rewrite the 4 and we rewrite the 8. So it's really 4, it's something to the 3x equals something to the x plus 1. And at this point in math, you are pretty comfortable with the fact that 4 is 2 squared. And I hope you are also pretty comfortable with the fact that 8 is 2 cubed. Now, what we learned is that you multiply the exponents. So this is 2 to the 6x equals 2 to the 3x plus 3. It's a 3. Now, at this point, it says if b to the x equals b to the y, then x equals y. You've got 2's. See, your base is the same. There's a 2, there's a 2. So it's really 6x equals 3x plus 3. It went from being a scary algebra 2 problem to just being a nice, simple little algebra problem. We're going to subtract the 3x. We get 3x is 3. We get x is 1. That's a 1, a positive 1. And we don't need to check it because we started with an exponential. We only need to check when we start with logarithms. All right, here we go again. It says solve the exponential function, and we're at 2 to the 4x equals 32 to the x minus 1. Oh no, we have a 2, we have a 32. What do we do? I remember where a 32 comes from. 32 is something. Do you remember? It's 2 to the 5th power. 2 to the 5th power. So now we multiply our exponents. So this is 2 to the 4x equals 2 to the 5x minus 5. Our bases are now the same. Okay, remember, you can pause me. I'm only going fast because I know I taught you this yesterday. So if you're learning this for the first time, please pause it and do the math by yourself. If I'm going too fast, just pause me and do it step by step. Okay, so x is 5, and I don't need to check it because I started with an exponential. All right, when it's not convenient to write each side of an exponential equation using the same base, you can solve the equation by taking the logarithm of each side. All right, let's go on to this next example. Look at this. It's 2 to the x equals 7. It's a 7. You can't write a 7 like a 2. You know, on this last example, it was a 32. Well, 32 is no big deal. That's 2 to the 5th. 7 is not 2 to anything. So you're stuck. And what I've taught you is when you're stuck, look at the form you're in and rewrite it in an equivalent form. We are in exponential form and we're stuck. So we're going to write it in logarithm form. I just did that. It was not magic. That is how you go from exponential form to logarithmic form. You take the base and that becomes the base of your logarithm. You go over to the equal side and that becomes your of. And then the to the part, the to the x, is what becomes your equals. Now, you know what's magical? It's solved for x. We didn't actually do any math. It says equals x. We were solving for x. We're done. You can make that an approximation in your calculator if you want. We did during the lesson yesterday, but I'm not going to right now. Okay, look at this. It's solved. It's 4 to the x equals 15. We're stuck. We don't know what to do, but we're in exponential form. So what we're going to do is rewrite it. Pause me. See if you can get it done before I do. It's log base 4 of 15 equals x. Did we solve it for x? Why, yes, we did. Again, it's a little trickier looking. Look at this. You have an exponential form. It's 10 to the 2x minus 3. But then you have a plus 4 hanging out and an equals 21. The rules of solving are the same. You want to get the x by itself. The way to get the x by itself is first get rid of all these friends. So start by subtracting the 4. So we have 10 to the 2x minus 3 equals 17. Now we're in the same exact spot we were in for the last example. You have an exponential on one side, you have it equal to a number on this side. What do? You're stuck. When you're stuck, you rewrite. So this is log base 10 of 17 equals 2x minus 3. All right, now right here I want you to stop. Log base 10 is just a log. You don't need to write the 10. Now, it's just a math problem. We're solving to get that x by itself, so we're going to add 3 to both sides. You are not allowed to touch that 17. You are not allowed to touch the 17. You simply add the 3 over there. The log of 17 is its own big yucky decimal number. Now we're solving, so we're going to divide by 2 both sides. So look at this beautiful answer. It's huge. It's x equals log of 17. Then the plus 3 is separate. All of it is over a 2, all of it. Make sure it's all over 2. That's the exact answer. You could plug it in your calculator, but like I said, I'm not giving decimals right now. Okay, here we go again. Here's another example just to make sure you know how to do it. I'm just going to run through it real fast since I know I did it with you yesterday, so go ahead and put me on pause and try it out. I start by subtracting the 3 from both sides. That's 22. I'm stuck, so I take the log base 5 of 22 and set it equal to x plus 2. I subtract the 2 on both sides, zoop, and I'm done. Beautiful, exact answer. Okay, in your foldable, you're turning now to where it says solve log functions. There's 8 examples. This is where we began this video. You were finishing those last 2 examples from yesterday. Go ahead, if you're learning this for the first time, you want to be in the solve log functions, and we're going to do these 6 together now. It says log base b of x is equal to log base b of y if x equals y. If and only if, so it goes both ways. So look at this. You have the log with the same base equals the log with the same base. What that really means is 5x minus 1 is equal to x plus 7. Done. That's it. It went from being a yucky algebra 2 problem to just being a nice little algebra problem. Now we're going to solve for x just like we always solve for x no matter what we're doing. It's 4x, it equals 8, so x equals 2. Now we have to wait. We started with a log. When you start with a logarithm, that means you have to check your answer. You have to check and make sure it works because logarithms have a domain restriction. If it's the parent function, it's all these x's that are greater than or equal to, or greater than, not equal to, sorry, just greater than 0. So we're going to check here by putting a 2 in. So 5 times 2 is 10, and 10 minus 1 is 9. So this would be a 9. 9 is positive, so that's all good. Put a 2 in here. 2 plus 7 is 9. Hey, guess what? It's the same number, and it's positive. So it checks. 2 checks. Done. All right, check this out. Solve. It's a log equals a log. It's a log base 4 equals a log base 4. It doesn't get better than that. You're ready to go. Rock and roll this. X plus 3 equals 8x plus 17. Bam. Done. Now it's just a nice algebra problem. We can handle this no problem. So I get, what is this? Negative 14 equals 7x. X is negative 2. Whoa, negative 2? I thought you said x could never be negative 2. It's true. In the parent function, the log of x, you cannot put a negative 2. But can we put a negative 2 here? Well, check it out. If you put a negative 2 plus 3 is a 1. And if you put a negative 2 here, 8 times negative 2 is negative 16. Negative 16 plus 17 is a 1. They are the same positive number, so negative 2 actually checks, even though in a parent log function it wouldn't work. Now, why is that? Go with me for just a second. What have we learned about shifting? When it's on the inside, it's right and left. So this log, like normally we're thinking about our logs whoosh like that. This log is a log with a x plus 3. So it's a shift to the left 3, and that's why negative 2 would work. Tricky that. Okay, it says when it's not convenient to write both sides of the equation as a logarithmic expression with the same base, you can do something called exponentiate each side of the equation. So over here we have solve log base 5 of 3x plus 1, and it's equal to 2. We're like, oh, okay, there's one log on this side and it's equal to a number. We're stuck. We don't know what to do. Whenever you get stuck, you rewrite. So this is really 5 to the 2 equals 3x plus 1. What on earth did I just do? I wrote it from logarithm form to exponential form. That's all I did. Now I'm like, hey, that's 25. I got this. 24 equals 3x. X is 8. All right, does 8 check? If I put an 8 in here, I get 3 times 8. 3 times 8 is 24. 24 plus 1 is 25. So this is the log base 5 of 25, and it is supposed to equal 2. Well, I could plug it in the calculator, but this is like saying log base 5 of 5 squared. Log base 5 of 5 would cancel, leaving the 2. Yes, 2 equals 2. 8 checks. We are just hopping along here. All right, solve. It's log base 4 of x plus 3. It equals 2. You're like, wait, it's 1 log equals a number. I'm stuck. But I'm in logarithm form. So what can I do? I need to write it in exponential form. So the base is 4 to the 2 power equals x plus 3. So I've got 16 equals x plus 3. X is 13. Well, does it check? 13 plus 3 is 16, so I have log base 4 of 16 is supposed to equal 2. That's like saying log base 4 of 4 squared. Hey, 2 equals 2, it checks. It just is a note down here because the domain of a logarithmic function generally does not include all real numbers. You should be sure to check for extraneous solutions. Well, we're doing that. If you start with a log, you check. All right. This is not a log. What is this? This is a natural log. A natural log. Which means there's an invisible little e down here. Okay, so now when we go to rewrite this in exponential form, it's e to the power of 2 equals x plus 3. What did I do? I saw that it was in logarithm form, which meant I was stuck, and so I wrote it in exponential form. I am no longer stuck. That's just e squared minus 3 equals x. Now we're going to check it. This is the natural log. Notice I left some space for the x. Do you see that? I left space for the x. And I'm going to put e squared minus 3 in there. Well, the minus 3 and the plus 3 are going to get together and go away, and I'm going to get the natural log of e squared equals 2. You should all already see it. What is the natural log of e? It's gone. 2 does equal 2. Just like that, this checks. So the whole yucky thing is your answer. Look at this, we're at our last one before those 2 we already did. Okay, it's a natural log equals a natural log. Yes, finally. Because when a log equals a log, that's the easy kind where you just set them equal to each other and you solve it like an algebra problem. So subtract your x, add your 7, you get 10 equals x. Now you have to check it. That would be 13. 20 minus 7 would be 13. Hey, same positive number. It checks. Okay, here's example 13 again. You can just pause it here if you need to look at it again. Here's example 14 again. You can pause it here if you need to look at it again. And then we're doing the entire 6.6 worksheet that is in our packet. I hope you are having a great day, you guys.